start with direct method of Lyapunov, that is basically for linear system. In this we will study direct method of Lyapunov stability for linear systems, an example. Then we will see Converse Lyapunov theorem for linear system, again we will see one example. Now about the direct method of Lyapunov stability for linear system. As I told last time that there are many criteria are available for checking the stability of a linear system, particularly Routh criteria, root locus, Nyquist plot, Boolean plot. The main purpose of Lyapunov is for checking the stability of a non-linear system, but it is found that along with this taking the stability of a non-linear system, this Lyapunov criteria is also useful for checking the stability of a linear system. Last time you have seen that this Lyapunov criteria gives the sufficient condition for stability of a system for non-linear system, but when we apply Lyapunov for checking the stability of a linear system, it is found that this criteria gives necessary and sufficient condition for stability of the system. Therefore, this criteria is an alternative to Routh criteria for checking the stability of the system, and in this case there is no need to calculate the eigenvalues. So, just see here, this method is useful for checking the stability analysis of linear system. It is an alternative approach to Routh criteria. In this approach there is no need to calculate actual eigenvalues, because you know eigenvalues plays important role in stability. If eigenvalues on the right hand side, system is stable, left hand side is stable, but here there is no need to calculate the actual eigenvalues. The concept used in this approach can be extended to use in checking the stability of non-linear system, that is the concept of direct approach can be extended for checking the stability of non-linear system. Now about the direct method of Lyapunov. So, consider a linear autonomous system, unforced system, which is described by x dot equals to Ax. A is the system matrix, and how to check the stability of this? Stability of this system is governed by A matrix. If you calculate the eigenvalues of A, you can get the stability of the system. That is, if the eigenvalues of A, this is left side of the S plane, system is stable, and if the eigenvalues of A lies on the right hand side, system is unstable. Now we are seeing the alternative approach. So it is said that, or Lyapunov direct method said that the system is stable in the large at the origin if and only if the given symmetric positive definite matrix Q there exists a symmetric positive definite matrix P, which is the unique solution of A transpose P plus PA equals to minus Q. So it is said that if you consider Q as positive definite, you have to consider Q as positive definite matrix, then determine the values of P that determine the P matrix, and it is observed that if P is comes to be positive definite, if P is positive definite, then we can say that this A is a stable system, and whenever we take P we have to consider as a real symmetric matrix, that is the rows and columns are same. So that is very important criteria for checking the stability of the system, and you will find that this particular simple formula A transpose P plus PA equals to minus Q, it is used in various applications. It is useful in checking the controllability observability of the system. It is also useful in the model order reactions. So this approach has multi-purpose applications. It is not only used for stability, for other control aspects. Now this A transpose P plus P equals to Q, that means when Q we consider as a positive matrix, then calculate the P. If P comes positive definite, then we can say that the system is stable, otherwise system is unstable, and this gives necessary and sufficient condition for the stability of the system. Now question has come in mind, how this equation has come, how we can say that A transpose P plus P equals to minus Q. Now we will start deriving this. Now we take say x dot equal to x, this is a plant, this system. Now what we take in Lyapunov, the concept is based on the function, that is the positive neck function, and that positive function we can express in a quadratic form, because when the given system in a quadratic form, that particular matrix in that form is always a symmetric matrix. Therefore, here we are considering V of x equal to x transpose Px. This is in quadratic form. This P is real symmetric matrix. Now, the concept of Lyapunov is based on the energy Vs function. Now, when the system become unstable, or sorry, when the system is stable, when the system is stable when V dot x is less than 0. That is the concept of the energy. So, V of x we have taken x transpose P into x. Now, we want V dot x. So, what we do, we will determine V dot x. This V dot x, that is equal to x dot transpose Px plus x transpose Px dot. That is the normal methodology of differentiation we have used, that is x dot transpose Px plus x transpose Px dot. So, what we are knowing? We are knowing x dot equals to x. So, when we put here x dot transpose, so we can replace x dot equals to x and we make it transpose. So, here we can write down as x dot equals to x transpose into Px plus x transpose P. What is x dot? X dot equals to x, so we replace here. Now, here Ax transpose. So, Ax transpose is nothing but x transpose A transpose. So, here we can write down as x transpose A transpose P into x plus x transpose P into A into x. Now, after this equation can be written as x transpose, here x transpose, here x transpose we are taking outside. So, we can write down as A transpose P plus PA and x is there, so you can get x outside. So, x transpose A transpose P plus PA. Now, here what is here A transpose P PA, that we have got. But here it is say x transpose P plus P equals to minus q. How this q will come? Now, why this q will come? Because for stability of this A, V dot x must be negative definite, that is V dot x must be less than 0. So, here in order to get V dot less than 0, what we can write, x transpose, I can write this as a q into x. So, now V dot x, x transpose minus qx, if this is the case, then our A is stable. Therefore, we have written x transpose minus q into x. Now, we can equate this equation. So, after equating this equation, we will get A transpose P plus PA equal to minus q. So, this is the final result. That means, in order to check the stability of A, we have to assume q as positive definite matrix and then calculate the P. If P comes to be positive definite, then system is stable, otherwise system is unstable. Now, we have to see some example based on this, and then we will see what is the converse Lyapunov approach. So, prior to this one, we start solving one example. Now, here we start solving it. So, x dot equal to 0 1 minus 1 minus 2 x plus 0 1 u. This is the system, x dot equals to 0 1 minus 1 minus 2 x plus 0 1 into u. Now, we have to check the stability of this system, and the concept which we have to use, that is a Lyapunov direct approach. Okay. Now, we have written the state space model as 0 1 minus 1 minus 2 x plus 0 into u. Now, if you want to check the stability of this system, so how to check the stability of this system? The stability of this system, we can take this A, we can take this as A matrix, and we will calculate the eigenvalues of this matrix. If you write down this eigenvalue of the matrix as lambda I minus A equal to 0, you can get the eigenvalues of the system. So, if you solve this, so what we will get? We will get the eigenvalues of the system as lambda plus 2 plus 1 equals to 0. So, we will get it as lambda square plus 2 lambda plus 1 equals to 0. So, lambda 1 plus 1 whole square equals to 0. So, lambda equals to minus 1 minus 1. So, it is simply 0 1 minus 1 minus 2 x 0 1 u. So, this is A matrix. Stability is determined by calculating only the eigenvalues. So, system is found to be stable. Now, what here we have to do? Here we have to use the concept of the Lyapunov, that is a direct approach. So, what we can do here? We can write down as A transpose P plus P A equal to minus Q. Now, A transpose P plus P A equals to minus Q. Now, here if you write down this equation as, that is A transpose, that is 0 minus 1 1 minus 2, and this P we can take it as P11 P12, here P12, here P22, and here again P11 P12 P12, here P22, and what is A matrix? A matrix as 0 1 minus 1 minus 2, and Q as 1 0 0 1, and this is minus 1. So, we have written this equation A transpose P plus P equals to minus Q. This equation is there. So, P is the real symmetric matrix, that is why we have taken P12, that is equal to P12, that is P12 equals to P21, but here both are same, that is why P12 equal to P12, same like this. Now, we solve this equation. So, after solving this equation, we can get the result as minus P12 minus P22 P11 minus 2 P12, this is P12 minus 2 P22 plus minus P12 P11 minus 2 P12, here minus P22, here P12 minus 2 P22, this is equal to minus 1 0 0 minus 1. So, how we have got this? So, here we will find that the 0 is multiplied with P11, minus 1 is multiplied by P12, so we will get P12. Then here 0 and minus 1 is multiplied with respect to P12 and P22, so we got 0 multiplied by P12 0, so we got P22. Similarly, here 1 is multiplied by P11, we get P11, then this minus 2 multiplied by P12 we will get this. Then similarly, here 1 multiplied by P12 will get this, and this minus 2 into P22 will get this. Similarly, this side we have got these results, and now we again solve it. So, after solving we will get minus 2 P12 P11 minus 2 P12 minus P22, then here P11 minus 2 P12 minus P22, and here we will get 2 P12 minus 4 P22, and here we will get again same minus 1 0 0 minus 1. That is what we have done. We have added the elements of this both matrices. This let us say matrix is C and D. The C and D we have added. So, we have got these results. Now, what we want? We want respective values of P11, P12 and P22. So, what we will get? So, we can get it as minus 2 times P12 equals to minus 1. So, this equal to this. So, what we will get? We will get P12 equal to 1 by 2. Now, we have got P12. So, what we want? We want P12 and will have P22. So, here what we will get? Here we will get this 2 P12 minus 4 P22 equals to minus 1. So, if we compare this equation, we can easily get P22. So, here we solve it as 2 times P12 minus 4 times P22 equals to minus 1. Now, you replace the P12 in these equations. So, we will get it as 2 into 1 by 2 minus 4 into P22 equals to minus 1. Now, here 1 minus 4 times P22 equal to minus 1. So, finally, P22 get it at 1 by 2. So, we have got P12, P22. Now, what to be determined? That is P11. So, here we take this equation, we have to compare with this. So, here we can write down as P11 minus 2 times P12 minus P22 equal to 0. Now, here P11 minus 2 P12, what is P12? P12 is 1 by 2 and P22 is also 1 by 2. So, we can write down like this equal to 0, and after solving this we will get it as P11 equal to 3 by 2. So, we got all values of P11, P12 and P22. So, now we write down in a matrix form this P equal to P11, P12, P12, P22, and here we can write down as this. P11 is 3 by 2. What is P12? P12 is 1 by 2, 1 by 2, and what is P22? P22 is also 1 by 2. So, we got a P, and what is the concept of stability? We have to check the definiteness of the P. So, we will find that in order to check the definites, we have to use the Sylvester criteria, and for Sylvester criteria we have seen earlier that we have to take principal minors. So, here we find that first principal minus is 3 by 2 is greater than 0, and next about other principal minors is complete determinant. So, 3 by 2 multiplied by 1 by 2 minus 1 by 2 into 1 by 2, that is what we will get here. 3 by 2 multiplied 1 by 2, 1 by 2 into 1 by 2. So, 3 by 2 into 1 by 2 minus 1 by 2 into 1 by 2. So, we will get it at 3 by 4 minus 1 by 4. So, we get 2 by 4, that is equals to 1 by 4, and it is greater than 0. So, we will find that this particular matrix P is positive definite because it 3 by 2 is greater than 0. Similarly, after solving this, that 3 by 2 multiplied by 1 by 2 minus 1 by 2 into 1 by 2, that is 3 by 2 into 3 by 4 minus 1 by 4. So, 2 by 4, 1 by, that is equals to 1 by 2. So, 1 by 2 greater than 0, 3 by 2 greater than 0. It means that this system A, which we are to consider, is a positive definite system, that is your given system matrix A is stable system, that is defining Q, calculating the P, we have got a system, a stable system. So, this is example. Now, here we have taken the case just like A transpose P plus PA equals to minus Q. Here we have defined Q and calculated the P. Can we do it in reverse that way? That is, in order to check the stability of A, what we will do? We will consider initially P as a positive definite matrix, and we calculate the Q matrix, and we see what result we will get. So, in order to tackle this, we will see the example. Now, we start with an example. Suppose matrix A is given as -2, 5, 0, -2. Now, we check the stability of this system A by conventional approach, that is we will write lambda I minus A. So, it is given as lambda plus 2 minus 5, 0, lambda plus 2. So, after solving this, you will get lambda plus 2 whole square, that is equal to 0, that means lambda equal to -2 and -2. That means we can say that first lambda 1 equals to -2, lambda 2 equal to -2. Now, this system is stable. Now, we check the stability of this matrix A using Lyapunov approach, that is we write A transpose P plus PA equal to minus Q. So, here we will use the direct approach, that means in direct approach we assume Q as positive definite matrix and then we calculate the P matrix. If P is positive definite, then we can say that system A is stable. So, now we replace A as minus 2 0 5 minus 2. So, this is basically a transpose of A, that is this A transpose and this is A. So, this particular part is nothing but the transpose of A. Now, the P matrix P11, P12, P12, P22. Now, this P we have written. Now, about this PA. So, we write as P11, P12, P12, P22 and A matrix as minus 2, 5, 0, minus 2 and this is equal to minus Q means minus 1, 0, 0, minus 1. Now, we have to solve these equations. So, after solving this equation we will get minus 4 P11, 5 P11, minus 4 P12, 5 P11, minus 4 P12, 10 P12, minus 4 P22 equal to minus 1, 0, 0, minus 1. Now, we equate minus 4 P11 equal to minus 1, this equal to 0, this part equal to 0 and this equal to minus 1. So, after solving this we will get P11 equal to 1 by 4, P12 equal to 5 by 16 and P22 equal to 33 by 32. So, now this P can be written as P11, P12, P12 and P22, that is equal to 1 by 4, 5 by 16, 5 by 16, 33 by 32. So, now we use the concept of Sylvester's. So, principal minors will take as 1 by 4. So, this 1 by 4 greater than 0 and here second principal minor, that is complete determinant. If you write, we will get 1 by 4 multiplied by 33 by 32 minus 5 by 16 whole square equal to 0.1602 and this is greater than 0. So, we will find that all the principal minors are greater than 0. It means that this P is positive definite and therefore, we can say that by means of direct method the system is stable. Now, we try for a converse Lyapunov approach, that we will try converse Lyapunov approach. So, in converse Lyapunov approach we write A transpose P plus PA equal to minus Q. So, in the converse Lyapunov approach we assume P as positive matrix and we calculate the Q. If the Q is positive definite, the system is stable. So, as per the convention we should get Q as positive definite when we are considering P as positive definite. Now, we will see for this problem what result we will get. So, here we take same A matrix as minus 2 5 0 minus 2, and now this Q equal to minus A transpose P plus PA, and in this case the P which we have to assume as positive net, so we write down as 1 0 0 1. So now we calculate Q, so Q equal to minus A transpose means here minus 2 0 5 minus 2, P matrix as 1 0 0 1 plus this P matrix as again same thing 1 0 0 1, and here A matrix as minus 2 5 0 minus 2. Now we multiply this, then multiply this, and finally we will get Q as 4 minus 5 minus 5 4. Now we again check the principal minus for this matrix Q. So our first principal minus is 4 greater than 0, and about the second principal minus we will find that will 4 minus 5 4, and here we will get 16 minus 25 equal to minus 9, and which is less than 0. That means this particular matrix Q belongs to indefinite, and therefore as per Converse Lyapunov approach the system is unstable, but actual system is stable. Actual system is stable. Therefore, for any system, when we want to check the stability, we have to use direct Lyapunov approach. We can't use Converse Lyapunov approach. That is, for some class of problem, Converse Lyapunov approach may give incorrect result. Now these are some references: Ajay Nagaraj, Gopal, D. Roy Choudhury, and we will find that the more application of this A transpose P plus PA equals to minus Q is given in this B N Datta, and again more application is also given in this particular book. Thank you.